Hey guys, I'm back with a new video. So in the previous video, we'll learn about the synchronous and asynchronous JavaScript programming concepts. So in this video, let me introduce you to a very important concept called as the event loop. Now an event loop is a mechanism that helps you to execute async code in JavaScript. It helps us to work with callback functions, promises that we use in our async code, which we will see in subsequent videos. Now let me explain the concept of event loop with a code example. So in my app.js file, I will define some functions here. So first I will define an arrow function and I will name it as play game. So this is an arrow function and I will log to the console. We are playing games, nothing productive to do these days. Then I will define another function and I will name it as write code. This is also an arrow function and I will log to the console. Enough of playing games, let us write some code. Now let us define a settimeout function that will invoke the write code function after 1 second. So I will say settimeout, and after 1 second I will trigger the write code function, and let us invoke the play game function now. So play game. Okay, now here comes the concept of call stack. So for understanding that, let us move to the whiteboard, and after that we will see the output for this code. So back in my whiteboard, I will select a pen first and will understand this code line by line. Now here comes the concept of call stack, as I told you, which comes into picture when you execute your JavaScript code. Now let us see what happens under the hood when your JavaScript code gets executed. So we have a stack and we have a message queue. So this is our call stack and this is our message queue, or you can say callback queue. Now with the call stack, we have web APIs that will manage the DOM APIs, timers, callbacks, HTTP requests and more, so which will be handled by the message queue. Now when the above code gets executed, the first thing that will happen is that these functions will get created. So the functions that we are having here, which is the play game function and the write code function, will get created. Okay, and then the first function that will get triggered is the settimeout function. So the settimeout function will get pushed to the call stack. So I'm writing setto. So once it is done, it will get popped off from the stack so that the timer is still running behind the scenes. So we have registered a timer that is running behind the scene and is getting managed by the browser. This callback function, which is our arrow function, will get registered in our message queue. So here we will be having the callback function, that is this one, and it will get registered in the message queue. So this will trigger write code, and this is present here in the message queue. Now the function inside the settimeout will not get triggered until the timer is done. So the timer is running and this callback function will not get triggered until the timer is done. The other code will not get blocked and then the play game function will run. Now the play game function gets invoked and a new record for the play game function will get pushed to the stack. So this is already out because we have registered the callback function in the message queue. Now we have the play game. Now the play game function is sitting on the top of the stack. It's pushed to the stack. So what will happen here is that the play game function will get executed even before the execution of the settimeout. Okay, this function, which is the callback function, will not get triggered, but the play game function will get triggered first. So this is delayed. This will run later. Okay, now the play game function will get executed even before the execution of the timeout, and the timeout is supposed to trigger the callback function, which is sitting in the message queue. and your timer is running behind the scenes while your other code will not get blocked and is still running. Now inside the play game function, as you can see, we are just having a console log. Okay, and this console log will get pushed to the call stack. So I will push this console log which pertains to play game function to the call stack. So console log. Okay, so what will happen, it will get pushed to the call stack right above the play game function. Now when the timer gets completed at some instance of time, so the timer is running, as I told you, it is still running behind the scenes. Now we need some mechanism to inform the JavaScript engine that the write code function that we registered as a callback function, which is this. So this callback function is sitting as CB, or you can say callback, is sitting in the very first record in the message queue, because we know that the queue is a FIFO data structure that is first in first out. So it is sitting at the front of the queue. Okay, so this is your very first callback that got registered in the message queue. So the write code function that we registered as a callback for the timer should get triggered, and for this we have yet another data structure, that is the message queue. So this is known as message queue. Now each browser can have its own implementation of the message queue data structure to manage the callbacks. So here we will be managing all our asynchronous callbacks. Here all the callbacks will be managed that will execute once the timer is done, in case of set timeout, or maybe when the results from an async call or an asynchronous HTTP request has arrived. Now in the message queue, the callback that holds the write code function, so this is your callback that you pass to the set timeout function, and this is holding the write code method or function. This will get registered in your message queue, as you can see, and is made to wait there, and the callback function is not executed yet. It just got registered in our message queue. So only the code that ran was pertaining to the play game function, and the log inside it ran. So we got this as our output. The set timeout did ran, but it didn't executed the write code function. It just registered the callback into the message queue. But the first statement that got logged to the console was, we are playing games, nothing productive to do these days. Okay, and the call stack is empty again once the log is done. So once your log is done, this function is done. So both will get popped off the stack, and you have an empty stack again. Okay, so our code that ran was pertaining to play game and the log inside it, and your call stack is empty again, as you can see. Now is the time to grab the callback pertaining to write code method into our call stack. So this callback function is waiting to get triggered. Okay, so the callback pertaining to write code is currently registered in our message queue, and now it wants to go into the call stack. So any function that you want to execute must be pushed to the call stack in order for it to get executed. So this will now go into our call stack. So the callback will now go to the call stack. So here it comes to the call stack. But for this function to get executed, we require the event loop. I already told you in one of the videos that the callback functions are executed by the browser. For example, when we talked about a button having an event listener for the click event, and once the button gets clicked, a callback function gets triggered that receives the event object. Now that callback function is triggered by none other than the event loop in JavaScript. Now the event loop, just like the call stack and the message queue, is present in your browser. The event loop has one simple job: to constantly monitor your call stack and the message queue. So it monitors your call stack and the message queue. Okay, so if it finds that the call stack is empty, it will grab the callback function that is sitting in your message queue, which is asynchronous of course, and it will give it to the call stack. So the callback is now sitting in the call stack so that it can effectively get executed. So within the callback, we have the write code function, because this is our callback, as you can see, and it has the write code function inside it, which is waiting to get executed, and then the log within it will get executed, and finally they get popped off the stack. So once we have the callback, once it is done, it will get popped off the stack and write code function ran. So we get enough of playing games. Let us write some code. So once it is popped off the stack, your stack is again empty at the end. Now our message queue is finally empty and our call stack is also empty. So once both are empty, the entire code is done. So this is what happens under the hood when you hand over the callback functions to the web APIs, and everything is managed by this event loop. This ensures that your JavaScript code in the end will never get blocked. So this was all about the video on event loop in JavaScript. So if you liked the video, do give it a thumbs up, subscribe to the channel and hit the bell icon. Let's catch up in the next video.